Welcome to part 3 of our second week together. Today, in this discussion, we're going to be looking a little bit more at the detailed relationship between samples and populations. And really the question of sample and population is about the question that we're asking. And as we go through this discussion, you'll begin to see why that's true. So let's talk about populations and samples together. The main idea that I want us to walk away from this discussion with is how a sample is drawn from a larger population. And we'll talk about why that matters and what it means in statistics in a moment. But for now, let's take an example. Let's say we're looking at readmission within the United States. And the United States has 48 contiguous states. It includes Washington, D.C., Alaska, Hawaii, and surrounding territories. So if we're talking about readmissions within the United States, we would be talking about all of those categories: contiguous states, outlying states, Washington, D.C., and territories. So 4 different categories. And if we want to understand readmissions in the contiguous United States, that dynamic perhaps could be different than in the peripheral states, or different than the District of Columbia or our territories. So when we define population, that's a crucial first step in our question definition, problem definition, that will guide us in our statistical analysis. So if we want to understand readmissions, let's say for a moment we're looking at readmissions within the 48 contiguous United States. And we're going to include Washington, D.C. as a state, as a part of that analysis. So that would be our target population. All hospitals who take Medicare patients in the 48 contiguous United States, including the District of Columbia. But it perhaps could be impractical for us to do detailed work at all of the hospitals in all of the contiguous United States in the district. So we may want to define a sample, a subset of those hospitals that we'd like to look at to get a better understanding of readmissions. And so if we create sampling definitions, criteria that we'll use for drawing hospitals out of our whole population of hospitals into a sample. And the goal in that work is to be able to understand a smaller subset to help us understand the larger. And so if we continue with this example and we talk about a study at 5 hospitals within the 48 contiguous United States and the District of Columbia, certainly that's far from all hospitals taking Medicare. It's only 5. And we measure something about those hospitals, and perhaps it could be something along the lines of their excess readmission ratio. And we find in that sample of 5, the excess readmission ratio is distributed like this. We all know that to be essentially normal distribution. And this red bar represents the mean of the excess readmission ratio in those 5 hospitals. But if we look at the population as a whole, let's say for example, we have data on all those hospital excess readmission ratios. And we want to compare how this sample relates to the population. We would be comparing the mean of our sample to the mean of the population. We'll talk about how to do that in subsequent weeks, but for now I want us to understand the concept that by looking at 5, we're hoping to understand the experience of all. So the relationship between the population and the sample is designed such that the sample could speak to the population as a whole. So this is where inferential statistics come in. Inferential statistics are when we're trying to make an inference or a conclusion about our population based on a sample. Descriptive statistics are things like our means and our medians and our variance and our data distributions. Those help us understand the particular sample of those 5 hospitals. But if we want to understand the experience of all hospitals, we want to draw conclusions from the 5 that relate to the whole. And that's where we derive inferences. And we derive those inferences using statistics. So we'll talk about specific tools and specific statistics as we move forward in the course. But that's the basis of what inferential statistics is. Again, trying to understand the experience of the entire population based on what we do know and can measure about a subset of that population. So in our next section together this week, I'm going to give SPSS examples from our data to show how populations and samples are related to each other, to show how descriptive statistics about variable distributions can be used to help inform our analysis. So come back to our next section and we will do SPSS on all of these topics together. So thank you very much and have a delightful day in life and with your numbers.